So, I actually had to borrow one of these today. Whoop. Enter N. Thank you. So the first slides, which you're going to see, is basically kind of looking at what's physical science, you know. But we're calling physical science this. What do other people call it? Oh, are you serious? It's tired too. Oh, okay. So now you have, I noticed on your slides, you have, it's like Finding Waldo, right? Okay, you have the formal, natural, humanistic, kind of across the top there. We're going to be talking about, probably won't get to it today, but eventually we'll talk about what do we look for to make it a science? Like, what is science? Well, you probably already have a sense of maybe what it is or what it isn't. We'll kind of talk about that. But you can talk about science as either being formal, natural science, humanistic, because I actually have colleagues that teach psychology that they're like, oh, psychology, that's the real science. And I'm like, are you serious, dude? Come on. Okay, but they are a science. They have hallmarks of science. Math is a science. You might not think of it, but in this flowchart it is. Different ways to look at science. So this is another way to look at science. And it looks like I took out these two blanks right here. I took out physical and biological. Okay. Of the natural sciences, which actually I'm more comfortable with the natural sciences, right? Of the natural sciences, I know this much about biology. It's beautiful. It's a wonderful science. And our daughter's going to biology. I'm like, are you sure? Okay. But I know a lot more, not everything by far, not everything, but about physical sciences. And again, in this case, you can see the physical sciences is broken up as physics, chemistry, astronomy, earth science. Notice they didn't break out meteorology or weather. Just another flowchart. Looks like I took off biological sciences here. Okay, so this one's similar to the one we looked at before. With regard to natural sciences, it breaks out to physical science and biological science. This one's a little bit different. Oh, looks like I kind of took off this one too. Physical science actually then is broken down into, this is more kind of what this textbook is geared towards. Physics, chemistry, it's even in the order we're going to cover. Astronomy, meteorology, geology, but of course would be earth science. And then earth and space science kind of takes astronomy, meteorology, geology together. Again, my vision for coming up with PHS120 was, and there's already a textbook out there for that, but it's like they're so related. You know, the whole what happens on the atomic level, you know, is related to what happens on a larger scale, even a larger scale. There's atmosphere. It's just beautiful. What did I take out here? That one's a really busy one. Looks like I just took out mathematics up there at the top. And it looks like I also took out law and ethics. You know, if the people get in a room and start kind of arguing what's the core science, a lot of times it will come down to this stuff, in even biology, is based on math. Start with math and then things kind of branch off from there. Okay. All right, so if I were to say the scientific method, you guys have heard of that before. And everybody learns a little bit different. So what are some terms that you come to mind when you say scientific method? In terms of people, things you do. Hypothesis. Hypothesis. Great. Definitely. What else? Question. I like that. Question. Yep. Anything else? What about you have a question, you hypothesis is what you think maybe is going on. How do you see if it is or not? Experimentation. Yep. And there's different ways to look at this. We're talking about the scientific method, but I kind of think as these three is kind of a loop. You just kind of go, doing that loop. You have with your experimentations, it might say, well, your original question, how you thought it worked, your experimentation, your thumbs up, should I do? This is great. And then you say, well, I need to further investigate and make sure that I do more experimentations. It doesn't go against my hypothesis. Okay. So what happens, starts letter T, what happens if everything's a green light? And what if your hypothesis seems to pass all of your experimentations? Starts letter T. Theory, yep. Theory. And if you're playing checkers, if you get to your opponent's side, they put an extra piece on you and they, what do you call it? Oh, king. You get king, okay? So you are king. See, this is why I use PowerPoint, because you can't read my writing. So this is kind of looped, kind of keep looping around and all that. This is generally what I think of the scientific method. So I have some slides on that. Okay, so it looks like a busy slide, but it's basically what we talked about. Okay, starts with what you see, observations. You ask a question, you propose an explanation, which is your hypothesis. You test your hypothesis. You have a couple of options here. They kind of did the colors wrong here. To me, they should have made this red, reject hypothesis, and they should have made this green, accept hypothesis. If you have the green light, you accept it, and you go ahead and you don't stop there, because what you don't want to do is present something as a theory and it's wrong, okay? The cool thing about scientists is they're really cliquey. Like there are physics and special branches of physics where those scientists talk, okay, and they do this, and they really want to, they're like little kids, they want to shoot each other down. So it's called peer review system. Here's another way to look at the scientific method. Again, it's a little different, but it has similar to, if you look closely, it's got these elements in there. It's just busier. This one, ask a question, you do some research, you come up with a hypothesis, again, you experiment, you look at your results, were your results true? Again, why make that red? I think it should be green. If your results are true, then this says report your results. I would go ahead and say I probably want a loop. If they're partially true or just false, you need to kind of adjust your hypothesis and take another step at it. Well, we've got a couple other, and I think we'll take a running start at this tomorrow, or not tomorrow, no lab tomorrow. Next time will be lecture in here on Friday. But we'll pick up with the next slide on Friday. And remember, bring a calculator Friday. I'll also have some of my little cheat calculators too, in case you forget. But we're gonna kind of see if we can all play nice with our calculators. So let me know if you have any questions. Otherwise, I will see you on Friday.